And of course, it's been billed as the most anticipated event of the weekend, gents. So
no pressure.
No pressure. Take it away. Take it away.
Awesome. Thanks very much for the intro. I actually wanted to get a video on screen over a fireplace, but we couldn't quite get it in time.
Yeah. Do you know where Fireside Chat came from?
I have no idea.
I think it's Roosevelt, the president. I'm probably pronouncing that incorrectly, my Australian accent, but yeah, apparently he did, well, one of the presidents did a chat by a fireplace back in the day before we were born, and hence the name Fireside Chat. This was before television and stuff. Apparently, if you didn't know where Fireside Chat comes from.
I didn't. A great mentor of mine, actually, a guy called Krill, he ran a business and sold it for many, many dollars. And he had this walking chat, and what he did, he was a Sydney resident, and he memorised a 30-minute route and a 45-minute loop. And so if you want to go for a chat, you know, he would, rather than having it in the office, he'd go out, go for a bit of a walk, and because he memorised the path, he never had to think about where he was going. The problem was that he used to deliver bad news on the short route, and his staff quickly realised that if they turn left at Hyde Park, they're in trouble. Anyway, on topic. We just wanted a bit of a chat. We don't really have too much of an agenda. We're going to talk about disruption and innovation, which is a pretty broad topic. But before we get too far in the detail there, I just want to sort of introduce ourselves. You know, this is being live streamed, and normally when you go to formal presentations, things people say turn your mobile phones off. I want to do the opposite. Make sure everyone has their mobile phones on silent, please. The Twitter hashtag is MMFSYB. I am SEBECKMAS. Dave is EEVblog. Yep. So please tweet away. I won't be doing it myself, but we'll be retweeting and everything else at the end of it. But Dave, do you want to just give a quick intro to yourself for those who, you know, the very few people in this room who aren't familiar with who you are?
Well, there's a few t-shirts I can see. Awesome, guys. Yeah, I'm Dave Jones from the Electronics Engineering video blog, full-time YouTuber. One of, I don't know, probably a dozen in the country who do it full-time. It's been my full-time gig for 3.5 years now. And I make crazy electronics engineering YouTube videos. I'm up to like 700 videos, something like that. And yeah, and it's my full-time business. And I also do a radio show called The Amp Hour. That's every week. I call it a radio show, but it doesn't actually go out on the wire. It's podcast. It's a podcast. Okay, I admit it.
Probably gets more.
You know, it sounds better, radio show. You know, I put it on my business card. You know, radio host. You know, it sounds impressive. So, yeah, I'm a full-time video blogger, and I've got 165,000 YouTube subscribers, which in the scheme of things worldwide is bugger all. Really, it's, you know, it's some of the gamer YouTubers, they've got like 20 million subscribers. And
the fashionistas who just put makeup on every morning.
Yes. And I've got like 26 million views, which isn't many. Some YouTubers out there get 26 million views on one video, easily. So, yeah, I'm small fry, but hey, it's a living.
Still a lot more than me. I probably got about 10 subscribers.
Excellent.
For my 2 videos.
I started at 10. Like, I thought that's as many as I'd ever get. You know? It just grew.
So how did you get started?
In the YouTube business or engineering?
In engineering.
In engineering, being an electronics hobbyist, which is another word for maker these days. Maker term didn't exist when I was a boy. I won't tell you how old I am, but that was a long time ago in a galaxy far, far away. And yeah, I was like 5 or 6 or something like that, and I liked taking apart stuff. So my parents didn't like that, so they got me one of these, who remembers the Tandy, 50-in-1 kit with the spring terminals, right? One of those hobby kits back in the day. This is before the internet. Some of you young people don't remember that. But yeah, and that's how it started, and I've been an electronics hobbyist ever since, and since then I've worked in the industry for 20 years as an electronics design engineer, and now I do YouTube videos full time. So I'm not really an engineer anymore, more of a entertainer, educator, that sort of thing.
Oh, I disagree with that. I think once you're an engineer,
always an engineer, yeah. I'm always got 10 half unfinished projects. Who's got an unfinished project? Yeah, see? Yeah, exactly. I got 10 of them.
My parents, my parents didn't like the fact that I pulled things apart, because I was great at pulling them apart, but I wasn't necessarily that good at putting them back together afterwards. So there's a skill set in both. We were having a chat just before outside, and we both reminisced on starting out with the Talking Electronics.
Talking Electronics, yes.
Right. one of my first experiences in actually building electronics and selling electronics was in those little electronic radio transmitters, also known as bugs. I used to sell them at school. I was only 12 years old. I used to sell them at school for $50 a little pop. You could either have it in a...
That was a lot of money back in the day.
It was a lot. It was $24 for the parts, a bit of time. It was great fun. And I used to sort of distance myself from the usage. I said, no, these are for education purposes only. I got into a lot of trouble at school when these things started popping up in teachers' lounges and conference rooms and stuff. And that put a very quick end to my short career in selling electronics.
But you did go into engineering.
I did get into engineering.
Awesome
So,
work.
a bit about me. I'm actually a weapons engineer. I served the Navy for 10 years as a weapons electronics engineer. Went to the Defence Academy and built a whole little cool prototypes and tools there. I did my thesis was on a bit of technology which lands unmanned aircraft in the back of warships with a laser scanning device, which if we'd been a little bit better with our patent definition, we would have knocked out Microsoft Connect, because it operates pretty much the same way. So you cannot use a Microsoft Connect to land a military aircraft in the back of a warship, which would infringe my patent. Unfortunately, we didn't see take the unmanned aircraft helicopter, turn it sideways and dance up and down in front of it for entertainment. We didn't see that. So you can't, the reverse isn't true. If the reverse had been true, we'd be better with our patent definition. It'd be a very different situation right now. I'd probably have better clothes and yeah.
How much did you get paid for your patent? I got paid $1 for mine. I went out and I bought half a muffin. With my $1. The company had to give me $1 for my patent.
You got paid $1 more than me. Yeah, it's unfortunately that patent never went anywhere. But anyway, technology moves so fast. What was your most expensive mistake? That was probably one of your cheapest mistakes.
Expensive mistake. Not expensive in terms of dollars, but I can remember my first job. I was 17. I started young. Long story, don't ask. Yes, I was qualified at 17. It's bizarre. And first job, and the company was under pressure. So it was like a security system. Anyway, microprocessor control, Z80, very advanced for the day. And we were like pulling a midnight thing, trying to get this thing ready for something tomorrow, the next day. I can't remember what it was. We had to demo the damn thing. And the software guys are burning the code. You had to burn it into an EEPROM back then. You know, you had to UV erase the damn things, and anyway, they gave that to me and I rushed over to the hardware, prototype this new firmware that would make the thing work. I plugged it in backwards and blew up our sole remaining EEPROM, so that just ruined that. I mean, it was just not expensive in terms of dollars, but in terms of company reputation, and I was the young kid there, you know, and oops, the magic smoke escaped.
I still remember programming Z80s with dip switches. You know, clocking through the registers. Totally. Which now I'm into software. I actually think that provides software engineers with a very healthy appreciation of how computers work. Do you think they should be teaching Z80 or any of the older technologies, clocking things through with physical switches as an appreciation for what can go wrong and how hard it is?
Well, that's a tough one, because they teach, you know, engineering education is a big complex topic, and there's so much to learn these days. I would say yes, I'd love to see that, but is there time for them to do that in such a wide-ranging course these days? I don't know. So I'm going to fence it on that one.
So if you're not going to university, how do you think is the best way to start getting into electronics and disruption and things like that, to start learning?
Build stuff. Fail. Biggest thing you can do is fail, okay? If you're not failing, you're not learning. If you build a project, you go and buy your little kit from, Freetronics here or something, you assemble it, you solder it together, you're all proud, you turn it on and all the lights come on and it works. Great, you've learned how to solder a kit, okay, that's okay. But if it doesn't work, then that's when you really start your learning, because you've got to troubleshoot the thing. Why didn't it damn well work? And then you've got to figure it out, use your test gear, use your skills, figure out the circuit. That's the way to do it. Build and fail.
I still remember a rather embarrassing story, but I'll recount it now. When I was about 8 years old, I got my first ever multimeter, and I'm going, yeah, great. And I had no idea what the difference between volts and amps and everything was.
Analog or digital?
It was a digital one.
Oh,
I know. My old man had an analog one, so it was a really old school analog one, but this is my first time, my own little one. It was one of those little bright yellow ones. It probably cost $5 now. In fact, I actually think as a kid you can actually make your own one these days. Yep. But anyway, I thought, this is great. And I thought, I need something to measure. And I looked around. This was at Christmas. I looked around. I saw a PowerPoint. So I stuck it in the PowerPoint, turned it on to amps, and blew the whole thing up. Because, yeah, you don't do that.
Oops.
Yeah, so that was my first failure, if you like, at hardware. And I learned a lot that day about, don't stick things in PowerPoints when you don't know.
I saved up my pocket money, got my first 20 range analog voltmeter. I was so proud, came home, blew the arse out of a few minutes. Beauty. But you learn, hey, don't put a current mode across a voltage source.
So moving forward now, hardware's a lot different now than it was when you're a little older than I am. But, so what do you think, how do you think hardware plays in the world of disrupting industries and disrupting technology? So we've got, there's Raspberry Pis, there's Arduinos, there's all sorts of prototype boards, development boards that can go out that can make it accessible and easy. How do you think these play a role in moving technology forward?
Because it allows you to, the main reason is it allows you to prototype ideas right there and then on the spot, and the amount of processing you got in these things is just ridiculous. I mean, stuff you couldn't even dream of 5-10 years ago. Now you can get an ARM processor running at a gig or something in a $50 board. It's just crazy, and with HDMI interfaces, with all the and Wi-Fi integration is just insane. Prototyping, getting stuff, ideas up and running and failing early. That's an important thing. If you've got an idea, like me, you get them every day, you wake up on Google, you search your idea, somebody's already done it, or if somebody hasn't, you go, okay, how can I do it? So you go and search for, parts that might be able to do it, other stuff, and then prototype your idea really quickly, fail early.
Yeah, the thing with Faire, so it sort of transcends to my world. So what my company does, Blue Chilli, is we're an investment group. We invest in non-technical entrepreneurs, and we invest in software to get their tech businesses off the ground. So that's basically what we do. Haven't quite made the transition into hardware yet. Probably going to do that next year. I'm itching to do it, but my chief operating officer doesn't want me to. It's too expensive, he says.
But everyone's doing it. You jump on the bandwagon.
Exactly. Well, it's not
Every
a bad
venture
one.
capital in Silicon Valley is doing hardware startups.
Yeah, absolutely. So that's basically what we do. But the whole failing thing is really, really important. But you need to make sure that you're not planning to fail. If you plan to fail, then you're doing the wrong thing. The important thing about failure is actually learning from the failures. I think it's a distinction that needs to be really, really clear here. We're not advocating the use of just sticking things in PowerPoints and blowing them up and mucking around, although it is a lot of fun, let the smoke out. But it's more about learning from those failures, understanding why things blew up. I mean, I remember buying a really old radio from the tip, $5 or something from an amplifier. I was trying to fix it up. I turned this thing on, and basically all the capacitors blew up, and there was bits of cardboard everywhere. So it's like the question for me was, well, why did they blow up? And that's the thing there. So yes, I failed. I put the thing in around the wrong way, but so I needed to understand why this thing blew up and had. So I totally agree with that. Let's talk about the Internet of Things.
Oh God, the Internet of Things.
You brought it up, venture capital, Silicon Valley. That's what they're into. There's a great silicon. So the Internet of Things is basically in connecting hardware devices and everything to the internet, and then doing something with that. Hopefully, doing something useful with that. And this is not just about tracking people's movements, things like that. It's about doing really, really interesting things. And one of the examples I like to use on this is a Silicon Valley business called My Lively. Now, My Lively is a hub that you stick in your grandma's house. And then you've got all these little sensors, and you put a sensor on the fridge door, you put a sensor on the toilet seat, you put a sensor on your gran, you put your sensor on everything else. And rather than just being about track my gran, what this thing here does is that it picks up regular patterns and usages that your grandma's doing at home. And then it sends you an alert when it detects something that's not right. So it's like, oh, your gran didn't make coffee that morning in the normal time she does. Something could be wrong, so you then go call her up and see what's happening. So this is a great example of the Internet of Things. So what are you seeing as...
Well, it's not about the hardware in that case, right? No. The hardware's commodity these days. Any one of you can go out and buy a $50 kit over there at Maker Faire, and you can do an Internet of Things application. It's so easy. But the value is in the algorithm, it's in the software, it's in the cloud, it's in the whatever you want, however you want to implement that thing, then that's where the value is. The problem with the Internet of Things is that somebody said it's the new pet rock, okay? I wish I'd come up with that. It's the new pet rock. You get it, right? You've got this lovely little, it's a farting gnome, right? You buy a farting gnome and it tweets every time it farts. Okay, great, that's fantastic. I want one of those, right? And then the novelty wears off and it becomes a pet rock and it's useless. You have to, you can't just do Internet of Things for the sake of it. You can't Internet enable your widget, your device, just for the sake of it.
There has to be an application for it.
There has to be a genuine need, genuine application for it. Otherwise you just, just join in the bandwagon and, well, it's pointless. I'm sorry.
Well, so you said something very interesting there, which was that hardware is becoming a commodity. Right. So how do you see the roles of electrical engineers in the future playing out, given that hardware is getting easier and easier, and it's actually becoming more about software now in terms of the software application on top of hardware?
But you see, it's you've got to differentiate between getting an idea up and running for one of those prototype boards, be it a Raspberry Pi or an Intel Galileo board or whatever it is, and actually engineering a real product. This is where engineering comes into it, right?
So what's the difference?
The difference is hardware is hard, okay? Hardware is really hard. If you haven't done it before, you buy a board or you build up your breadboard prototype, you solder it together on proto board or whatever, and it's and it works. It's real easy. It's a whole different ball game taking that into production and producing 5,000 of them, 10,000 or 100,000, depending on how successful your Kickstarter campaign is. And it's a whole different. It's all about supply chain management, right? I've got a product I sell. It's a world's simplest circuit, right? I spend all my time in supply chain management. Bill of materials, buying parts, finding suppliers, oops, they've run out of stock, I need an alternative part, I need this, I need that. Manufacturing problems, surface mount soldering issues, the higher your complexity design goes, the more issues you're going to have soldering in production. Where do you get it made? Do you have people on the ground there? Are they going to screw you over? Are you going to run out of money?
So definitely the role of the hardware engineer is definitely increased in scope.
It is still there. It's still there.
Good.
And not just a hardware engineer. There's a big difference between being able to lay out a board and being able to actually manufacture one and follow it through. So the more broader skill set you got, the better it is, even if you're using outside contractors to do stuff. Because if you run a Kickstarter campaign these days, Indiegogo, any crowdfunding campaign that involves hardware, you will be inundated before the campaign's even finished with companies wanting to offer you their services in terms of, we'll manufacture it for you, we'll ship it for you. Well, shipping, geez, there's a whole issue in its own right. Bloody shipping's a pain in the arse.
Yeah, make sure if you run a Kickstarter campaign, you don't use yourself as a storeroom. Make sure it's dropped. You don't want to be handling that.
And there's all these people who offer their services for you for a lousy 5% of your Kickstarter money, 10%, and you've got 10 people doing that, there goes all your profit margin.
So I've had an idea for a Kickstarter campaign.
Oh, tell us.
Right, so a little while ago I was given a suitcase by Samsonite in exchange for using my face in a Virgin magazine. I totally sold myself out, it was awesome. I wasn't going to say that, there are children about, but yes. Anyway, so I've got this suitcase, it's a great little suitcase. It's got 4 little wheels at the bottom and you drag it around behind you. And I thought, this dragging around thing's a bit archaic here. What I really want to do is stick some motors on the bottom, put a little circuit on there, a couple of batteries, and have it so it follows me around. So imagine me walking down through the airport with a bright, blue suitcase about 5 metres behind me going,
with a SWAT team following it.
Absolutely, that's a problem. So that's probably why it won't work on Kickstarter. I still want to do it though, not because I want to sell lots of these things, because I think it's going to be freaking cool to do. Right, so tell me about your Kickstarter experience.
My Kickstarter, my first one was on the Australian website. Possible.
Yep.
Possible. And I made it just a little PCB ruler, right? It's nothing, okay? It's a piece of fiberglass, okay? Because a couple of fans asked for it, right? And I thought, I'll make a couple of hundred of them, right? And I put it on there. Next thing I know, I've got 30 grand in the bank, and a couple of thousand people want these damn things. And then I found out I shipped some to, I made them myself, packed them myself, shipped them. Then I found that, they fell out the edges of the envelope, right? So these people all half of them received empty envelopes. Goodness, hey. So I had to get special tear-proof envelopes, a special material. I had to import those from the US to post a bloody little bit of fiberglass. It was ridiculous. And then I got screwed over by the mailing house. I thought, I go to a big mailing house and they'll mail it for me. No problem, it was a reasonable rate, I had enough profit margin in there. And no, they sent it via some dodgy company who took 2 months to ship the damn things. And it's just a complete balls up.
So you did it
Absolutely. I did it again.
What was the next one?
Next one was actually on the Kickstarter website. And it was a product I've manufactured before, right, which is all fine and dandy. And I thought, I thought everyone had already bought one. Right, everyone who wanted one, I've already exhausted my market, but I'll just do it for a bit of fun. I wanted to see how Kickstarter worked, and I'm in the business, I talk about it, so, I thought it'd be nice. And all of a sudden, there's $110,000 sitting in my bank account, and I got to ship, a couple of thousand of these things. And 6 months, that was 6 months ago, I'm still shipping the odd one that didn't arrive 6 months later.
Did you manufacture all those yourself?
I manufactured them here in Sydney, yeah. I took pride in that. I wanted to keep everything local, didn't want to shop it off to China because there's so many companies, you know, it's cheaper. But you need people on the ground over there to make sure they don't rip you off or, you know, or just screw things up generally. So I got it manufactured here in Sydney and yeah, worked out great.
Awesome. That concern about shipping things off to other countries that don't necessarily have the same appreciation for IP protection, I've heard that come up a few times actually. And in fact, a mate of mine who's a hardware engineer as well actually manufactured a circuit where he drilled out the EEPROM reprogramming. So he pulled out I think it was a pick. He basically cut it in half, followed where the leads for the bus to basically reprogram this thing went into it, mapped out where it was on XY, and then on an XY drill, basically just drilled through these pre-programmed EEPROMs so that no one could actually steal it and copy it and fill it up with epoxy. So that's the lengths that he went to for his widget. I can't even remember what the widget was. Is there a concern with IP and
they will rip you off. What I don't want to stereotype, and I shouldn't, but it's a realistic thing that happens in China, not just in China, but everyone talks about China, right? These manufacturing houses, they manufacture your widget, they'll manufacture the iPhone, they'll manufacture whatever, and then at night, 2 a.m. in the morning, they'll do a ghost run. And using all of the parts that have fallen off the pick and place machine, fallen off, and they've already been written off, so Apple don't know anything about it, right, or whoever's getting their phone menu or watch manufactured or whatever, and they'll put a secret run through, and they get shipped out the back door and sold on the black market. So when you go buy one of those, you know, dodgy ones on eBay, dodgy iPhone on eBay, it's actually a genuine iPhone made on the same production line, usually, unless you've been completely ripped off and then sucked in, and it's actually a genuine iPhone made on the same production line, but Apple didn't get a cent for it, right? It was already written off, and that sort of thing can happen. If you stay low profile, like, you know, nobody's going to rip off my product. It's just not worth the effort. You know, the market's not there for it. But, you know, if you get big, you get a Pebble watch or you get some other huge big Kickstarter, maybe someone might try and rip it off, but you can't stop them. If you try and stop it, you're just wasting your time. Don't bother. Assume you're going to get ripped off.
And yeah, that's right. So how do you see Kickstarter has changed the way prototypes and people get built? The one thing I love about Kickstarter and all those sort of crowdsourced crowdfunding campaigns is that it's customer validation before you've spent too much money building it. Right, you're selling all these products before you built one prototype. Yeah, I can do that. You sell thousands and thousands, if you're lucky, or hundreds and hundreds of this thing here. So it's real validation. So what are some of the things that you need to think about and be conscious about when you're actually running a Kickstarter campaign like that or similar for your prototype? What are some pitfalls to avoid?
First of all, how bloody easy is it to get money these days? You guys are just giving it away. The hardware project, this didn't exist 10 years ago, right? You had to bootstrap your project. By that I mean you had to fork out, $500,000, build your prototype, buy 5 kits worth of parts, sell your 5 kits, make a couple $100 profit, use that profit to then bootstrap and build some more, and then that's how you built your company. Now people just fall over themselves to give you damn money, like this guy here. Right, just go talk to him after the show and give you money. If you've got a software idea, it's just giving it out.
Not quite as easy as that.
Right. Yeah. Anyway, sorry, what was the question? I got sidetracked.
It wasn't how to get money.
It was pitfalls with Kickstarter.
Pitfalls with Kickstarter. That's right.
For God's sake, make sure you have a fully working prototype. None of that, because they've changed the rules recently. You used to be able to just do a 3D render, stuff like that, and that's just bullshit. Yeah. Okay, you've got to have a real prototype. Spend your own damn money first, okay? Spend some of your own money, get something real made, make sure you can manufacture it, do a little pilot run with a manufacturer of 10 units or something like that, make sure you can actually make them, and then do your Kickstarter campaign. You'll have a lot less hassle knowing that you can make it.
And make sure as well that you set your price high enough so that when you are looking at distribution, you're looking at mass manufacture, you've still got that margin there to make a little bit of money from it as well.
I've got a whole blog post on that, analysing how much you should actually charge above. The magic figure is about 2.5 times minimum. So if your widget sells for $100, if it costs $100, if it costs $100 to make it, you want to sell it for at least $250. That's allowing for it's allowing for a decent product margin, it's allowing for failure, it's allowing for screw up, all sorts of things, and it's allowing for a distributor margin, because if you don't ship it yourself, you've got to go through distributors. They're going to take their 40% markup. Yeah. And so there's a minimum figure. It's about 2.5 is the magic one.
And frankly, if a potato salad can make, a couple $100,000 on Kickstarter,
how much did they get in the end?
Oh, lots. I can't remember what it was. I stopped.
Awesome.
I thought about putting my own money into it actually, but I wasn't sure if he was going to ship to Australia. And frankly, I don't know if I wanted his potato salad after it got to Australia. But yeah. So let's talk about Australia. How much of a place do we have to play in the global sort of hardware innovation world?
As much as we always have. It's your ability to create. That's it. That's the only thing stopping you. You're not in the centre of the action here in Australia, in Sydney, or wherever in Australia, but all the infrastructure's here. You can do it all by the internet. You can order everything. I manufacture my products here, no problems whatsoever. Just if you're trying to compete at the really low end, the low margin end, you're just going to get beat. It's too expensive to ship stuff out of Australia, for example, and it's just not worth it. But high margin, high value niche products, absolutely.
Yeah, so quality.
Design them here, yeah, absolutely. Design them here, make them here, no problems whatsoever.
Yeah, actually, there's a great defence technology. I did spend some time in the Navy. Great defence technology out of Canberra. CEA Technologies is the name of the company, and they have the most advanced radar system in the world. Beats all the American stuff, hands down. In fact, our Anzac frigates have now started to employ it. It's called Faire. It's basically an active phased array radar system. Really detailed technology. Where I love it. I'm going to get a bit nerdy here, but where they actually. They found out that the standard way of using chemicals to etch away circuit boards for the type of frequencies they're involved with left an uneven profile on the edge, the microscopic edge, the edge of the copper.
It actually rounds off. That's a phenomenon. Yeah.
Exactly, so they had to use a laser cutter to actually get that really sharp edge, otherwise they weren't getting as much performance out of their radar system. Now that is really cool. That is really cool. This is an Australian company here selling global disruptive technology around the world. So there's definitely a place here in Australia where we can actually do that sort of stuff. Are there any other examples that you can think of?
Of Australian ones? Well, I've worked in the defence sector as well. I spent like a decade doing underwater sonar gear and stuff like that. We were world leaders in oil exploration, eco-friendly oil exploration equipment. World leaders, still are.
DSTO down in Adelaide?
No, that was Cersei Tallies here in Sydney. Yeah, Tallis in Sydney. And we were world leaders. And it's great. There's tons of niche examples like that if you have a look around. We're big in the medical devices. I think there's an exhibit here which is the Cochlea. There's a design awards, or there was last time I was here. International. Some great examples just over there. Take a look.
Well, that's an interesting thought. So the Cochlea is basically implanted hearing aids.
I've done some work for them which I shouldn't mention on their latest generation one, which isn't released yet.
Have you actually implanted anything in your body yet?
No, I haven't got. But Jonathan Oxer down at the Freetronics stand, he has an RFID microchip in his arm. If you go down to the Freetronics stand and ask him, oh, there he is. Hey, John. he's got a microchip in his arm. And you did that yourself.
I did. Yeah. They're doing the self.
He couldn't find a surgeon that would willing to do it.
I think vets do it though, don't they? Into animals, vets in the back of the thing?
Vets do it.
Self-implant. Yeah. I have actually thought about, because I'm always forgetting my Opal card at home. I'm just getting the Opal chip instead of my arm.
Right,
And just looking at the traffic guys, the security guards looking at me weirdly as I just wave my wrist over the come through.
I was just thinking about the other day. I was mentioning this new Opal card in Sydney, right? Why didn't they just use near-field communications with your card? Everyone's got a credit card with an NFC, near-field comms. Why do they have a separate card, separate systems? Why can't you just swipe your card that's already in your wallet? Stupid.
We've already got these things, or phones as well. Yeah. Why do you think Apple's taken so long to put NFC in their phones?
They held off putting an FM radio in for a long time. It was it's all to do with business and how they make money. For them, it's all about making money. Yeah. So I don't know why. I don't know the reason behind it. There's got to be a reason.
I can't think of it.
Because they can't make money from it. If they can't make money from it, then they're not going to put it in the phone. They make money from features they put in the phone.
Yeah.
So.
One of the awesome areas is coming out of the US in terms of disruption is just watching what Google's doing, and particularly Google Ventures, in terms of the investments they're making in the automotive space. Right, and this is quite pertinent.
The self-driving cars.
Self-driving cars, and the broader spectrum on that. So I just want to touch on this, given that Australia's car industry is self-driving and self-independent.
We still have a car industry.
Well, Apparently we do, yeah. So for those who aren't as familiar, so Google's made all these strategic investments in these technologies. They're all kind of independent, but when you start looking at the overall how they're all connected, it starts getting quite exciting. So they've got all this research into self-driving cars. They've got the Google Maps service that's got cars driving around and taking photographs of everything, every street, mapping out in 3D now, mapping all the streets around. They made an investment in Uber, which is the taxi app.
Yeah, that's right.
You can basically book a taxi via your mobile phone. So they've got an investment in Uber, and they spent $280 million. So it was a significant investment. And they've also got bought out Waze, which is an Israeli company that is social mapping. So you've got social mapping, people telling people where things are. You've got Uber, which is all about moving people around on demand. You've got self-driving cars. You start putting those three things together.
You can see the pieces come together. Somebody's thinking.
Someone's thinking. So yeah. I can see a day where we actually don't own cars anymore, where cars or car ownership is going to be sort of a fringe thing you do as an enthusiast, right? You buy a nice sports car because you want a sports car. You buy a car because you enjoy driving cars. And there's a few of us in the room, I'm sure, that will do that. But I think where the broader vision is going with the self-driving cars is that we don't actually own them anymore, and they just self-drive themselves around. And when you subscribe to a service, the self-driving cars, it hooks up to your Google Calendar. It knows that you need to be at work at 9 o'clock in the morning, so it'll be there at exactly 8:33 because it knows the traffic conditions. It's the perfect time to pick you up to get you there on time. It drives you to work. Now, rather than going and just plugging itself into a car park and being wasted, it then goes and does a delivery for someone else. It then goes and picks someone else up, and the car that actually picks you up at the end of the day could be completely different, but you don't care, right? You're just getting from A to B. So what do you think of that?
I'll just unplug myself from the Matrix. Hang on. Goodness. Yeah, it's a great concept. Will it take on? Will it catch on? Practically, people love to own stuff. People like the freedom of doing stuff. If you get delayed for a minute, you get pissed off, right? In the traffic, imagine having to wait for your car to turn up, or it doesn't show up because somebody else stole it, or somebody else hacked the system, or it broke down, or whatever. There's too many. As an engineer, as a design engineer, first, I can think of a million reasons why something won't work, and they're the first things that pop into my head. That's what that's what I do.
Yeah. That's a dangerous.
It's very non-visionary. Yeah. Very non-visionary of me, but it's ultimately somebody has to practically implement this, and it's the first time I've really thought about this. You just raised it, but give me 10 minutes, I could come up with 10 serious problems that need to be overcome. Probably doesn't mean they can't be.
Just check out EEVblog later on.
Yep.
You'll see a Kickstarter campaign for self-driving cars.
I'll steal that. Thank you. Is it open source?
Why not?
Well, it is now. It's public.
Yeah, is it public?
That's it. You didn't patent it. Too bad.
Actually, let's talk about open source and open source hardware. So my world software, open source software is quite prolific. They're everywhere. It's great examples of massive communities of tens of thousands of people working on single projects to actually get, for the betterment of the entire community, people donating their time. It's only just started happening in hardware. I mean, Arduino is probably the most prolific example of this, and it's still within closed doors. But how do you see the open source movement applying itself to hardware?
Well, you said it's fairly new. It's actually, I've been doing open source hardware for 20 plus years before it was called open source hardware. See, I got my projects published in the electronics magazines back before the internet, right? They were open designs. People have been freely publishing their designs for, since, the first wireless weekly magazine back in the 1920s. But the term is new, the movement is kind of new-ish, and it's got a new branding. And open source hardware is huge, but it still comes down to the fact, I think people like the idea more than actually contribute. They like the idea of having an open source thing, not because they can, just the ability to know that they can hack it. 99.9% of people won't, they just want an off-the-shelf solution, right? And that's fine, right? And that's what you have to cater for. If you're doing a Kickstarter campaign or you're doing something else and it is open source hardware, you can't just assume almost everyone is not going to contribute. They just want a finished product and that's it. But they love the idea of and then being able to build on top or something like that, and then maybe somebody will come along and build on top. It's ultimately though, is the collaborative aspect of open source hardware very difficult. It still comes down to designers like me really like to work on their own. It usually comes down to one person doing the bulk of the work, rather than, if you think you can get 10 different people helping you out design this, product, Yeah, good luck with that.
It could be also an iterative sort of process. So you build something, and someone builds on top of that. And someone builds on top of
3D printers are like that. You know, the early work with the rep wrap on the 3D printer, which, you know, turned into the early MakerBots, and then everyone else did it. And, you know, it's a very evolving thing. It's still evolving, you know, what, 10 years later or something like that. They're still not ready for, I don't think they're still ready for, you know, your average, you know, your kid under the tree, you know, open, oh, look, I got a 3D printer, you know, they're still a bit touchy. So that's the aspect where, you know, where people improving, making small improvements here and there can make big contributions to the community as a whole.
Yeah, well, it's interesting you say that about the 3D printers, about it's not quite there. Obviously, it's not quite at the point where you can plug a 3D printer in and just hit print and get a mobile phone. It's a long way from that, but I think the technology is coming significantly.
Oh, yeah.
MakerBot,
Totally.
One of the leaders in that space in terms of the thermoplastics. You got a 3D printer?
I do have 2 MakerBots.
Two MakerBots, yeah.
Yes.
And
they're a pain in the ass. I only just got, it didn't work, it basically didn't work. It was like, oh, it was horrid. And I just upgraded it like last week, and I got like a little extruder attachment for it, which fixed all the problems I was having, and that was designed by somebody in the community, right? MakerBot, they'd already been bought out by Stratasys and for $300 million or whatever. They still couldn't get their extruder working. One guy in his garage, I'm assuming it's a guy, sorry, and made this little, you know, extruder attachment which makes it all work, and everyone's happy now. So it's a fantastic product.
It's also an awesome example of how, you know, the little guy, I hate using that term, but the little guy is sort of disrupting the big manufacturer.
Yeah, totally.
Right, so how do you think hardware innovation plays in disrupting big technologies? I mean, you've got there's countless of examples of, you know, small or smaller companies taking on the big guys. One of the best examples, and, you know, I shamefully admit I've got a bit of a love affair with this guy, is Elon Musk and Tesla taking on the automotive industry.
Fantastic.
Right? And he's
automotive, solar, space, the whole works.
Yeah, awesome guy. But so here's an example of the little guy, although he's got a lot of funding behind him. The little guy taking on, you know, the big manufacturer. That's whole David Glass. Do you think it's possible for you to hack into the car in front of you?
Tesla, just mentioning Tesla, they just were at the world's biggest hacker conference. What's it called? DEF CON, thank you very much. Yeah, they're at DEF CON, and they brought their Tesla in, and open invitation. Everyone, hack our Tesla. Please, we'll, you know, if you do it, we'll give you a gold medal and a free tour of the factory. You know, there's probably 1,000 hackers around the world now trying to hack the Tesla, and it's probably possible.
Do you think the word hack is the wrong word? Because hacking in the hardware space means a positive thing, right? It's being able to take a couple of bits of hardware devices and make something cool out of it. Hacking in the software world has a very different and negative connotation associated with it.
Hacking in the hardware world, hacker spaces, right? They used to be called hacker spaces, right? There's one here in Sydney, and there's a few up the coast, down the coast, and people don't call them hacker spaces anymore. They call them maker spaces, right? Because hacker's a bad term. And because it's still got that connotation from the early 70s and John Draper and the, you know, Captain Crunch and all the,
right,
you know, the Woz with the blue box and the whole, sorry, we're nerding out on history.
Hacking the movie didn't actually help that at all.
Right.
Awesome. So look, that's basically what I was wanting to get a chat about. I actually want to open the floor to see if there's any questions from the room, and about anything at all. So please, does anyone have any questions at all?
Hardware, YouTube, software. Give me money,
right?
Please.
Big loud voice.
What is this MakerBot update to the extruder that you mentioned?
Oh, it's just it's like a spring loaded. They used to use like a plunger. They used to use a stupid plastic plunger you know, with friction to hold the filament. And like, what idiot designed that? It's ridiculous. You know, and so it's a little spring loaded attachment. It costs like 10 and 20 bucks. You can even 3D print your own. And and you just attach it to your existing head, and it puts proper spring tension on your filament as it feeds through, and it just works.
That's the ultimate rep wrap, though. Is the 3D printer that can print itself.
Yeah, and it isn't new. I think it's been around forever. Takes me a while.
I saw this about a week ago. There was the robot that folds itself out of paper. What these guys made is they basically sandwiched some polystyrene between some paper, because they found out that the polystyrene itself, when heated, would melt, and as it melted, it would contort into a shape. And by cutting certain lines in the substrate on top, the paper on top, this thing could fold into a shape. A couple of motors, a bit of the circuit, a few timing. Basically, they created a robot that folded itself out of paper, origami, and then walked away.
Sweet.
Really cool. Took 3 minutes. There's a great video on that on YouTube of this thing just sort of growing out of nothing, folding into, contorting to shape, and then walking away. Love it.
Have you seen a spider? There's a Hong Kong company who've developed this little tiny spider. You can buy the kit for like $600 or a finished product, and it's freaky. It really is. It walks like a spider, and it's got like 3 motors in each leg, so it can fully articulate, and it creeps and crawls, and it's got a big blue eye on it, so it looks really scary and all.
I don't think
it's great. I want one
of those.
Yeah, I think I'm going to have to order one. It's like $600. I'm going to get it. It's a tax write-off on the blog. It's okay.
Any other questions? Yep, down the front here.
Just in terms of, you're talking about Kickstarter and startup hardware, small manufacturers, that sort of thing. How do you see the role of government in being able to support those startup industries, and what more can government do currently to support that?
They can do an infinite amount more, because currently they do zero.
My logic on this is that if your business model or business idea relies government, your business model is screwed. I was going to use another word.
It's screwed, but it's good to help out. It's good to, maybe tax breaks for, electronics manufacturing here, for, people who set up manufacturing facilities. There's not many left in the country.
No.
In this country now, there is no ability to get production PCBs made. You cannot get them made here. You can get niche, real high performance 10, 12 layer military grade, the stuff you were talking about, the laser etch ones. There's 1 or 2 companies that still do that, but I could not get my PCBs manufactured here in Australia in only a couple of thousand volume, right? I was using it for my first run. I went to a guy in New Zealand, and then he said, no, I can't do the volume either when my Kickstarter campaign went in. And I had to get them made in China. So unfortunately my board is made in China, but my box is still made here. Box is made in Perth, my plastic box, fantastic. It's crazy. And the government just let it all go.
Well, they're going to have to work out something to do with all those old, sort of car manufacturing warehouses. So maybe we'll put a PCB lab in there.
It's not rocket science, it's a pick and place machine and a few people to operate it. It's, I don't know, give them some tax break in some way. Yeah.
Yes?
What do you see about these trends in the US of public makerspace and the libraries starting to open up? Do you see anything like that in here?
So the question was, where do we see the trends in public libraries in the US with makerspaces opening up? Are we seeing that sort of thing here happening? Yes, in fact there's one in Sydney, out on Oxford Street.
But is that public? Is that the government?
You pay, no, it's not government. No, I think you pay $30 or $60 a month or a week or whatever it is to go and borrow. But they've got 3D printers, they've got laser cutters, they've got a bit of a hardware space. They've got engineers in residence that come there. So it is having the transformation of library spaces is definitely a thing that a lot of people are putting a lot of attention into, because books are getting less and less and less relevant, and so they've got.
You think?
Yes. Now, unless you can turn books into self-folding robots, that kind of be cool. Right. But anyway, so yes, there's a movement there. Whether it's driven by government or just by councils, I'm not sure on that one there. But in terms of maker labs starting up, yes, we're starting to see that happening now. Well, at least I have in Sydney.
Right. I wasn't aware of that. I thought it was just yet another private one.
Oh no, this one is a private one.
Yeah, but it's
There's also a group called Hub, which has collaborative working environments all around the country, and they're starting to create more workshopy type things. There's a public school out in the northern beaches. In fact, it's the Northern Beaches Christian School. They've created this lab out there which has laser printers and that sort of stuff as well, and they're looking at ways to use that space after hours, because at 3:30 all the kids go home, and there's we've got all these fantastic facilities, how can we make that available to the public? So it is happening, but it's an organic movement rather than a government one.
You mentioned something there in that they have the people there with the skills.
Yes.
That's the important part of a hacker makerspace. Yes, the mentors, because you can buy your own 3D printer, you can buy your own laser cutter, it's only a couple of grand or whatever, people buy $1,000 phone these days, why can't they buy $1,000 laser cutter, right? So yeah, to have that sort of stuff is nice, but not necessarily essential. Where you need it is the skills and people to work with, encourage you, and form a business with, and that's where you meet people and they can help you out. But no, the government's putting jack all into it. It's ridiculous.
These things tend to come in waves. The 3D printer thing's been going pretty strongly since 2009, say, as a commercial sort of thing, and really sort of started to take off with cupcakes. There's been other things come along. The quadcopters have been an emerging thing. Wearable technologies are currently a big developing area. Where do you see the blue oceans of the next 3 or 4 years?
One thing that I'm excited, I don't have my phone with me, but right, if you got your phone, you know, they started out, they were just keys, right? You had to have the QWERTY keyboard on, you had the BlackBerry QWERTY keyboard, and then we got touch screens. They were crappy resistive touch screens. They were like, you know, you had to really press the damn thing. Then you got nice capacitive touch screens with gesture control, and you can rotate your photos, and you can swipe and all that sort of jazz, and you can, you know, virtual keyboard, and you can do the swipe thing, whatever that's called, bloody trademark. But now, like for $3, you can buy a 3D space gesture chip and incorporate that into your product. So now you can have your phone or your other product sitting here, and you can wave your hand here, and it can detect your hand in three-dimensional space using the, you know, the field and the capacitive effect and all that sort of stuff. And for $3 you can buy a chip that, you know, but nobody's doing anything creative with something like that yet.
That's really cool.
And that's, yeah, it's really cool. And then that will scale, then you can probably scale that up if you're smart to, you know, movement in a room like this, you know, and image tracking and stuff like that is going to get huge.
I think that's sort of one of the next waves we're going to see is just blurring the boundaries between having computers on you and having them where you actually have to proactively use it, and having a fallback on it is actually just part of what you're using. So, you know, Google Glass looks really dorky. I've got one. I never wear it anymore, unfortunately.
That's really failing. People are saying that's a failed. It won't be ready until 2020.
I'm actually going to put it back in its box and keep it for 20 years because I reckon it'd be worth something.
How did you get one here in Australia? Are you special?
I knew someone at Google in the US that shot me down one, yeah. I actually put this thing on for 3 weeks. I did not take it off. It drove my wife nuts at home. I did not take this thing off for three weeks, just to really experience what it was like to wear this thing on the head. It took me about 3 days to get over the fact I looked like a complete tool. 3 days, 3 full days where I was sort of nervous walking in the street and conscious that everyone was staring at me, and I just got used to that. And yeah, walked into shops and ordered stuff, and everyone's just looking at me weird, going, "Am I being recorded?" Yes, you are actually. If I wink at you, it takes a photo. But I see, and that's true. Actually, that's actually one of the cool things about it. It's like, how you doing? Yeah, I've got your photo. But where I see sort of the next sort of wave of this is that blurring that boundary. So Google Glass, you know, even the Gears and everything else, and the new watches coming out, it's still a device that you have to interact with. Whereas I see the future is more like that guy's, you know, RFID in his arm. It's as computing becomes part of our lives, and we don't actually have to make that positive distinction as I want to interact with that. It's just, it's around us, it's happening all the time, and it's making, yeah, it's ubiquitous, exactly. So Internet of Things is a wave of this. 3D printers are just dropping the price down for prototyping and technology. So all these things are coming to a point where computing power and computers are going to be ubiquitous and everywhere, and it becomes part of our life where we don't have to consciously think, I want to interact with something, it's just there. That's where I see it. And
there's other ways. Interviewed somebody on the Airpower radio show into haptics and things like that. If you don't know about haptics, it's getting feedback through your skin. So they're talking about, you know, like a very non-intrusive way. You know, if you're at a dinner party or something, you know, instead of tapping somebody on the leg, you know, let's leave. You know, you can it can.
You wink at them.
Yeah, and then you'll get like a heat sensation on the back of your neck because you might have some sort of sensory feedback through your skin. You know, and things like that. There's lots of emerging research and stuff like that going on in that area.
That's an area that the Teslas, the new cars, have actually failed in, because they've got that massive iPad-like screen in the centre. Yeah. There's no haptic feedback, and this thing in the centre console does everything from cruise control to radio to temperature. Now, the great thing about the older cars, I'll use that term, is that you can reach down there and you can feel around. You go, there's the volume.
Right.
There's the temperature. Crank that down. You can feel it. You've got that haptic feedback. You can touch. A massive touch screen. You got to look at it. And you're driving a car, it means you're not looking that way. So I'm actually expecting to see a lot of Teslas on the side of the road in the ditch as people are trying to reprogram their thing. Because one of the fundamental things they lacked was that haptic feedback, but it could be easily solved. I mean, you could even put in a speaker coil behind the screen, for example, to make that click noise when you touch a screen. You can feel it. I've touched it. I've got that.
Or it has a little finger in the back of the seat that pokes you. Hey, wake up and fall asleep. I want patent on that one. I just thought of that then. It's great.
Kickstarter campaign coming later. Yes. Any other questions? Yep.
There's a sort sort of pattern with Australian software technology entrepreneurs having to eventually relocate to the US to access funding and that kind of stuff. Do you think that it's feasible for an Australian hardware startup to grow to scale in a high volume, low margin area in Australia, or would they probably have to follow the same relocation to the US or some other place?
Did you say high volume, low margin?
Yeah.
As I said, low margin, high volume is next to impossible from Australia, unfortunately. I mean, like in the electronics hardware side of things, I don't know the other side of things, but
I'm not necessarily talking about the assembly and manufacture. I'm talking about the business and accessing funding. So, yeah, manufacturing and assembly, everything could be outsourced to
right.
Asia, but what about the company itself, and could it access funding to grow and scale?
So
here's your man.
So the question was, is there a requirement for entrepreneurs in the hardware software space to relocate to the US to get access to capital for high volume, low margin sort of businesses? I think you just take that high volume, low margin bit aside and just look at that core problem, which is access to capital. So I run a venture capital company here in Australia. We've got a $10 million fund, and we invest in startups, in digital startups, because digital startups don't require that expensive hardware prototyping stage.
Hardware is hard, like I said. Software just requires talent and time. That's it, two T's.
So what we're seeing is this trend now of, yes, I sort of 5 years ago, I totally agree with you. Yes, you need to go where your customers are, and ultimately, if you're looking for capital, your customers are venture capital companies in America, Silicon Valley, New York, Boston, a few other areas are the prime breeding grounds for all this. So yes, there's this movement of people going on there to access their capital. Good news is that those people are now coming back to Australia and reinvesting in locally. There was more VC funds set up in Australia in the last 12 months than the last 5 years, for example. So it is definitely an area that is improving. Unfortunately, culturally in Australia, we're not used to deploying risk capital or that venture capital into early stage businesses. The statistic I use is that on average, Australians per capita spend $12.70 per capita on the Melbourne Cup. Right, so we're not adverse to risk. We don't mind spending money on risk. $12.70 per capita on the Melbourne Cup, not horse racing, the Melbourne Cup. Whereas venture capital into startups, it's about $2.70 per capita. By contrast, America's around 100. So just to give you a complete idea of the difference there, right? So they're deploying a lot more capital into startups. Another statistic is in New York City alone, right? So New York State alone, more venture capital was put into one round, the angel round, which is a certain stage of venture capital. More capital, money, was put into companies at the angel round last month than was put into all companies in all rounds in Australia last year. Right, that's one state in New York, in the US. So there is definitely still a much larger industry in the US, that's obvious. But what we're seeing now is a trend of the American companies venture capital companies looking at Australians, because Australians are innovative. Australians do a lot of things with very little. We tend to be quite disruptive in the way we think, a bit more formal and progressed. And frankly, and this is an unfortunate realisation, but it's a positive, is that we're cheap. Right? It's a lot easier for a big US venture capital fund who is used to deploying millions and millions and millions of dollars into the American companies that ultimately fail to look to Australia, and it's because of all the other ingredients we've got, we can't afford to fail as expensively, which means that VCs are looking at here. And we've now got some great examples of that happening. Again, Canva is a Sydney-based startup that's just recently raised another couple of million, half from America, half from Australia. There's a great example down completely the other end, which is Campaign Monitor, raised $250 million from one VC fund about 6 months ago. And these guys, they've been around for about 10 years now. They're a fantastic business, $250 million of capital invested from the US. So they're still based in Sydney, right? They never want to leave the beach. They're very close to Cronulla. They want to go surfing all the time, right? Frankly, no one moves to Silicon Valley because it's a cool lifestyle, right? You don't go there because you want a nice weather or go for a beach, right? You live in Australia because it's a great place to be. And I think the VCs are definitely seeing that. So we're seeing a trend coming back the other way.
One last quick thing, because we're running out of time.
We are.
What is that? What about foreign investment laws? Does that play an issue there?
So foreign investment laws at the lower end of the scale doesn't necessarily become a problem. What's actually an interesting thing that's happening is the new visa laws have been introduced that allows wealthy investors overseas to basically buy a visa by investing, I think it's up to at least $5 million capital into Australia. Now, that's unfortunately one of the reasons why property prices are going through the roof, because that's one of the easiest ways to invest. But I think going back to your question before about what can government do to change this, is if you sort of tweak the rules a little bit and say it's property, but yes, it could be put into hardware startups or tech startups and things like that, we're going to have an interesting environment here. There's going to be a lot of external capital coming into Australia for them to buy the right to live here, but also it's going to promote Australian innovation.
Excellent. And I'm sorry, but our time is up.
We are
We're
up.
being given the wrap up. So thank you very much for joining us, guys. We'd love to take more questions, but unfortunately we're out of time.
Yeah, thank you, Dave, for the
But by
chat.
all means, we're hanging around. So, well, I'm hanging around.
I'm
So
hanging around.
come up and ask questions if you want.
Awesome.
Thanks, guys. Appreciate it.